Hello class. Today we are looking at section 9.4, simplifying and combining radical expressions. On page 675, it talks about the multiplication property of radicals. On the same page, it talks about the division property of radicals. On page 676, it gives the steps of the simplified form of a radical expression, and it has 4 steps there. On page 678, it talks about adding and subtracting radicals. Now turn to page 682 and look at number 25. It says simplify each expression, assume that all variables represent positive numbers. And we know variables are letters that represent an unknown number. Number 25. '25 has the cube root of 5x squared times the cube root of 25x. Now, the most important thing you want to pay attention to is that both parts have an index of 3. Notice you don't see anything between the two cube roots, so it is understood to be multiplied together. Now, we know that we see that index of 3, I need 3 of the same to bring it out of that root. Because both of these have a cube root, I can make this into one cube root. Break down 5, we know it's just 5 still. Break down 25, which is 5 times 5. Now break down your x's. I see x squared, so that's 2 x's. And I see x to the 1, that's an x. Now, I need 3 of the same to bring it out of the radical. I see 1 set of 5s and 1 set of x's. So my answer is 5x. Number 29. We are dividing. Okay, 29 has the square root of 98 x to the 3rd power divided by the square root of 2x. Again, both of the indexes are understood to be 2. So because both of them are understood to be 2, I can divide. Now we need to remember our properties of exponent rules. I know that when I divide, I subtract the exponents. Take your coefficients 98 and 92 and divide them. So 2 go into 98 49 times. Remember, you have an x to the 3rd over x to the 1. So 3 minus 1 is x squared. I need 2 of the same. So the square root of 49 is 7. And the square root of x squared is x. Number 31. I have the square root of 180 a b to the 4th divided by the square root of 5a b squared. We're going to divide first. My coefficients, 180 divided by 5 equals the square root of 36. Now, we want to subtract those a to the 1. So we know that a over a is going to cancel out to 1. And then we have b to the 4th divided by b to the 2nd. So 4 minus 2 is b to the 2nd. Okay, so again, remember those properties of exponents. When I divide, I subtract the exponents. So the a's canceled out. Or we can think of a to the 0 power equals 1. And then we have b to the fourth divided by b to the second, which is 4 minus 2, which is b to the second. I need two of the same. So the square root of 36 is 6. And square root of b to the second is b. And that is my answer. You do want to remember those absolute value rules that we talked about, but in this section they don't do the absolute value bars on this section. So we want to keep it the way the book has it set up. Okay, look at number 41. It says simplify the cube root of 80. Right here, I need 3 of the same. You can break down 80 however you like because it's going to all multiply back to 80. So multiply ever. Let's do some mental math. I know 8 times 10 is 80. Okay, let's break down 10. I know 2 times 5 is 10. So we know 10 times 8 is 80. And 2 times 5 is 10. Now, I need to break down that 8. Well, I know 4 times 2 is 8. And I know 2 times 2 is 4. So, let's do the math. 2 times 5 is 10. 10 times 2 is 20. 20 times 2 is 40. And 40 times 2 is back to 80. So, just check it very quickly. So, I broke down 80 into its prime factors. And I put it back under that radical. I need 3 of the same for it to come out of the root. I see 1 set of 2's. I am left with 2 and 5. It does not make a set. So 2 times 5 is 10. So my answer is 2 times the cube root of 10. So that's it on that one. This time on the previous ones, everything came out of the root, but in 41, everything did not come out the root. So just be careful with that. Let's try another one like that. Number 43. If we take the cube root of a negative number, that's okay. When we take the square root of a negative number, that's when it's not okay. It's not real. I need to break down negative 81. So let's break that down. Okay, we can put the signs in as we go. So let's do 81. Well, I know 9 times 9 is 81. So we're going to say 3 times 3 is 9. And then 3 times 3 again is still 9. So let's check that. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. But I want negative 81. So a negative times a negative is a positive. And a positive times a negative makes a negative. So there's so many ways you could do this. You could have had 3 negatives or just 1 negative. Because when I multiply everything back out, I need it to still say negative 81. But when you do math, you want to bring that negative sign out of the root. So that's why I made 3 negatives instead of just 1 negative. I see 3 negatives and I need 3 to be the same. So I have negative 3 times the cube root. And then the only thing remaining was that 3 by itself, that positive 3 by itself. So again, I want my leading term to be negative. So I did 3 negatives under the root so that way I can bring out a negative 3. And the only thing that was remaining under the root was a 3. Do not forget that when you write your answer, you do the cube root because you must write that 3. Okay, let's look at number 55. 55 says assume no denominators are 0. This time I have the 5th root of 3m to the 15th power divided by 32 n to the 10th power. Okay, so right here, I can start putting some things together. Now, very, very easy. I need 5 to be the same to come out of the root. I cannot break that 3 down anymore, but I can break down 32. Okay, so let's just do a practice our factor tree. I know that 8 times 4 is 32. 4 times 2 is 8. 2 times 2 is 4. 2 times 2 is 4. So I see 1, 2, 3, 4, 5 twos. So 5 twos get me back to 32. So in my denominator, I'm going to write 2 to the 5th power. And then bring down my m to the 15th power. And bring out my n to the 10th power. All I'm doing is dividing. So keep it very simple. So right here, I need 5 of the same. I know that 5 goes into 15 3 times. So I have m to the 3rd. I know 5 goes into 5 one time. So I'm left with 2. I know 5 goes into 10 twice. So I'm left with n to the 2nd. So if you notice, I got rid of the 2, the m, the n. I brought it out. But 3 is remaining under that root. So I have m to the 3rd divided by 2n squared times the 5th root of 3 still. Because 3 is remaining. Okay, so in the book, they do write it a little bit nicer than this. It looks a little ugly. And that's okay. We're going to fix it up like the book has it. So in the book, they write down a little different, but this is correct. But they have m to the 3rd times the 5th root of 3. And then they put it over 2 to the n squared. And you have to remember right here that the 5th root of 3 is understood to be in the numerator. So in the textbook, they wrote it in the numerator and put everything over 2n squared. Okay, let's go over that one more time. So right here, I broke down 32 and said 2 to the 5th power. Then I said, well, 5 goes in 15 3 times. I said 5 goes into 5 one time. So I wrote 2 down one time. 5 goes into 10 two times. So that's why I have n to the 2nd. But if you notice, I don't have 5 threes. So 3 has to stay under that root. And then I just clean my answer up a little bit to make it look a little nicer. Okay, let's try the next one. Let's look at number 63. Number 63. I have the square root of 175 a squared b to the 3rd. Okay? So right here, I want to break down 175. Well, I know it's divisible by 5. So when you're doing these, definitely look up your divisibility rules because that helps a lot. I want to jump up and say 25 times 7. Then I know 5 times 5 is 25. So I'm left with 5, 5, and 7. Those are my prime factors. So underneath my square root, I have 5 times 5 times 7 times a squared times, and I'm going to say b squared times b. Again, and I stress this over and over again, you can write these out so many different ways. But my index is understood to be a 2 there. So I need 2 of the same. I see 1 pair of 5s. I see 1 pair of A's, 1 pair of B's. But what do I not see? I don't see a pair of 7s, and I don't see a pair of B. So that's my final answer. So that 2 means I need 2 of the same. That's 1 pair of 5s, 1 pair of A's, and 1 pair of B's. 7 and B did not make a pair, so it has to go back under the radical. So if it makes a pair, take it out that radical. But if it does not make a pair, put it back in that root. Okay, so that's multiplying and dividing radicals. Very easy. So as you multiply and divide radicals, you want to still keep in mind your property of exponent rules. When multiplying, add the exponents. When dividing, subtract the exponents. When a power is raised to a power, you multiply them. When a base is raised to a zero power, it equals 1. When the exponent is negative, you move it on the opposite side of the fraction bar to make it positive. When the entire base is raised to a negative exponent, you write that reciprocal to make that outside exponent become positive only. Remember those rules. We've talked about this since the first day of class, so you have to remember those rules. Okay, let's go over adding and subtracting these radicals. One thing that we talked about on adding and subtracting radicals, the radicand, that's the part on the inside, must be the same in order for you to add or subtract them. If they're not the same, you cannot combine them. So if you look at number 77, I have a radicand of 98 and 50. They are not the same. So because they're not the same, I cannot put them together. But I can break down 98 and 50. So let's see if we break it down and see if it'll work. Okay, let's do our mental math, or do your factor tree, or get your calculator out and start crunching some numbers. The divisibility rules will help you know what numbers are divisible by 98. 98 is an even number, so I know off the top it's divisible by 2. So I know 2 times 49 is 98. Okay, what can I multiply to get 50? I know 2 times 25 is 50. Now, why did I do this like I didn't do this like the rest? Because you're used to me seeing me write it down to the prime numbers. But again, like I said, it's so many ways you can do these types of problems. This one, I'm doing it just a little different than what you're used to. If you don't like it, go back to doing all the prime numbers. So it'll be 2, 7, and 7. And then the second part will be 2, 5, and 5. If that's what you're comfortable with doing, do it. But I see something. This makes it very easy for me. Because I know the square root of 49 is 7. I can't break down that 2 anymore. And I know square root of 25 is 5. And I can't break down this 2. So if you can think of two factors that can give me 98, but one of the factors, I can take the square root of it. That's another way you can also break these radicals down. And that's how I did 77. It's a little different than the others, okay? If you don't like that strategy, then just break down all the numbers to its factor, to its prime factors, okay? But I do see something. The radicands are identical, so I can combine my coefficients. 7 minus 5 is 2. What's remaining is the square root of 2. Do not add those. It's going to say the square root of 2. That's my answer for number 77. Look at number 81. So 81, I have 3 times the square root of 54 plus 2 times the square root of 28 minus 4 times the square root of 96. Again, do a factor tree or apply those mental math skills to figure out what works. Now, I know that 54 is divisible by 2. So I have 3 times, I know that 2 times 27 is 54. Break down 27. I know 9 times 3 is 27. And I know 3 times 3 is 9. So let's check that to make sure we're good. 2 times 3 is 6. 6 times 3, 18. 18 times 3 is 54. Okay, or I said 2 going to 54 27 times, and I know it takes 3 threes to get 27 again. Break down 28. I do know 28 is divisible by 2. So 2 times 14 is 28. And 2 times 7 is 14. So I'm just multiplying. That's all I'm doing. Break down 96. So 96, I know that 2 times 48 is 96. Now break down 48. Well, I know that 6 times 8 is 48. 2 times 3 is 6. And for my 8, I need 3 2s. So that right there, it had a lot, but just look at it. So I'm going to make sure you kind of see it all before I go to the next step. Okay, so right here, I know that 2 going to 48. 2 going to 96 48 times. And I know that 6, 2 times 3 is 6, times 8, 2 times 2 times 2 is 8. So 6 times 8 gives me back to 48. Okay, so let's go back. We need to find a square root. We got to find pairs. I bring down my 3 here. Bring down your coefficient 3. Okay, that's your coefficient 3. I see a pair of 3s. One pair of 3s. 2 and 3 does not make a pair, so 2 times 3 is 6. It goes back under that radical. Okay, let's do it again. If you didn't understand that, we got 2 more times to look at it. Bring down that coefficient 2 times, I see 1 pair of 2s. And 7 stays under the radical. All right, let's look at it one more time. Bring down that coefficient 4. I see a pair of 2s. I see another pair of 2s. And I'm left over with 2 times 3, which is 6. Okay. So it looks a little ugly, but just take your time and look at it. Okay, let's talk about it one more time before we go on to the next step. I see my coefficient 3. I see 1 pair of 3s, so you bring it out. And then 2 times 3 is 6. Bring down your coefficient 2. I see 1 pair of 2. 7 is left over under the radical. Bring down your coefficient 4. I see 1 pair of 2s, a second pair of 2s, and 3 times 2 is 6 under that radical. Okay? So very important that you understand how I broke that down. And this is one of your questions you have on your SLO, so make sure you understand it. All right, let's go to the next step. 3 times 3 is 9 times the square root of 6. 2 times 2 is 4 times square root of 7. Plus 2 times 4 times 2 is 8. 8 times 2 is 16 times the square root of 6. Okay, so I see 2 like terms because they both have a radicand of 6. So I can put together 9 plus 16. So let's write the way the book has it. So for number 81, one typo. Originally it was a minus, so not a big deal. Just fix your sign right quick. Always good to check your answers. So we have 9 minus 16, which is negative 7 times the square root of 6. Okay, so again, we know 9 minus 16 is negative 7 square root of 6. And then they put that positive 4 square root of 7 as that leading term. When you write your answers out, you want your leading term to be positive. So they have 4 square root of 7 minus 7 square root of 6. Okay, and always check your answers and make sure you got your signs in the right place. Very important. Okay, so now let's keep moving. Let's look at number 85. 85 says simplify. In 85, we have a cube root this time. So we need 3 of the same to bring it out that radical. Number 85. So 85, I have the cube root of 32 minus the cube root of 108. One more key fact that I want to explain too is that your radicands must be the same, but your indexes must also be the same too to combine your like terms when you're adding and subtracting. You must have the same radicand and the index must be the same as well. When you're multiplying and dividing, the index part must be the same. When you're multiplying and dividing, your index must be the same. And when you're adding and subtracting, your index and the radicand must be the same. So keep those things in mind, okay? So let's break this down. I have the cube root. Think about 32. So I know that 32 divided by 2 is 16. So we have 2 times 16. And we know 16 is broken down to 4 times 4. So I got 5 more 2's. And we've already broken down the number 32. So we know that. Now do the cube root of 108. Okay, so we know 108 is divisible by 2. So we have 2 and 54. Okay, break down 54. I know 54 is 2 times 27. And I know 27 has 3 3's. Okay, so these numbers we've already seen, so we know how to break those down. Basically, just do a factor tree. If you don't like the factor tree, apply those mental math skills. And also study those divisibility rules, because the divisibility rules help you know what numbers are divisible by 32 and 108. I need 3 of the same. 3 of the same. So I see one set of 2's. And I have 2 times 2 left over, which is 4. Minus, I see one set of 3's times the cube root. And I see 2 times 2 left over there also. So my radicands index is the same, so I can combine my like terms. So 2 minus 3 is -1 times the cube root of 4. But in our book, they do not write that 1. So it's just negative cube root of 4. And we know it's understood to be a 1 as my, understood to be a -1 as my coefficient. Okay, so that is it for our section 9.4. Any questions or concerns, please let me know.